Well, Chakra, do you want to maybe just kick it off for us real quick?
Yep, sure. I'll take it over. All right. Hello, everyone. Thanks for joining from various parts of the world. So today we have two wonderful guests, Uma Mukkara and Nilanjan. We can call him Neil. And they are going to talk to us about chaos engineering, especially in the cloud native space with LitmusChaos open source project. And without further ado, I would like Nilanjan to take it away. Nilanjan, kick off.
Thank you so much. Just a single request. Can you please make Uma a panelist? Like he has just joined. Maybe I'll just stop sharing my screen so that Uma can start sharing. Yeah.
Can you guys hear me?
Yeah.
Yes, we can hear you.
All right. Hello, everyone. Sorry, I'm a bit late to join here, but very good morning to all of you. Thanks for the invitation here. Very happy to be here and talk about the new exciting world of chaos engineering and how we can do it with LitmusChaos, right? So I think the agenda for today, we have about an hour overall, right? And I can spend about 20 minutes on what is chaos engineering and why what of chaos engineering, and then what's the relevance of chaos. And then everybody has a question on, how do you go about chaos? What's the maturity model to think about, how to begin with, and where do you see chaos going in a few years within my organization, all that. Then we'll go a little bit into Litmus and the open source tool, and then Nilanjan will do a good detailed demo, right? And we can run this show for a very long also, anywhere from 30 minutes to 2 hours. But let's also keep asking the questions in Q&A. One of us will keep looking at the Q&A, right? So just before going in, a quick intro about myself. Uma Mukkara. I had co-founded a company called Chaos Native, which is now part of Harness. Before actually founding Chaos Native, I wrote Litmus along with Karthik in 2017 when I was running some SaaS operations, and I found the need for chaos engineering. I didn't like the tools that I had at that time, so I went ahead and wrote a tool for myself, which later open sourced and then became a popular one, which is now part of a CNCF as an incubating project. So that's my quick history. Right now, I'm at Harness building the same solutions for more enterprises, and at the same time extending the open source contributions with more power, right? So let's get back into that, and maybe Nilanjan, did you already introduce, or you want to do a quick intro?
I guess I didn't get the opportunity to formally introduce myself, so let me take a shot at it. So hello, everyone. My name is Nilanjan, and currently I'm working as a software engineering at Harness. I am also a core contributor to the LitmusChaos project, where I'm as part of the core team. I'm also contributing to the various chaos engineering efforts, core engineering, chaos engineering efforts. And basically, in my day-to-day life, I'm responsible for identifying the different scenarios in which chaos engineering can be applied, and therefore creating these chaos workflows and chaos experiments, as we would understand in this presentation, that what they are. I create these experiments so that our applications can be tested using chaos experiments. So yeah, see you in the demo.
All right.
Thanks,
Thank you. And just to make sure you're seeing the agenda slide, right? I got multiple monitors.
Yep, we can see.
Okay, perfect. So let's, why chaos engineering, what chaos engineering is very important. Some facts to start with is, which are undeniable, or the digital services are growing fast. Everybody is on the internet. Every service is on the internet. Everything is online. And the traffic rate is almost like, 20 to 50 times in the last few years, right, overall. And digital transformation started, last decade, but last few years have been, crazy, almost everything. And COVID situation has only made it more prominent, right? Now everybody works from home, even our lifestyles have changed, right? Everything is online. So this is also helped by the transformation of IT into cloud native, right? Many people are moving their legacy systems to cloud native driven by Kubernetes, right? And this also adds to the digital transformation happening faster. So because of this change, one another significant change is also happening in DevOps, right? DevOps itself was a transformation that happened in the last decade. But because of the cloud native transformation, there is a change happening within DevOps subsystem called cloud native DevOps, right? So what is cloud native DevOps? If you look at it, things are happening. The ability to ship faster is much higher, right? And there are a significant list of tools that are made available recently, right? You take CI and CD, there is a whole bunch of new tools available, right? Especially in the last few years, right? The way you do CI, the way you deploy, things have totally changed, right? The deployments happen almost always right now. It's not like every month, right, or every week. That's what we call cloud native DevOps. I just want all of us to understand here that this is one of the prime reasons, the significant increase in the digital traffic and also the DevOps ecosystem becoming much more dynamic, are two key reasons why chaos engineering as a technology become more relevant and more acceptable for adoption, right? I'll talk about it in a bit, right? So before we go to chaos engineering, let's also talk about service downtime. We have always talked about how important the reliability is, right? This is not a new requirement. It's always about, how many nines you have. Only difference is that service reliability was important only for super big businesses, and there were a bunch of them. But now service reliability is very important for everyone, even smaller businesses, because everybody is growing faster. User experience has become very, very important. Customers can get dissatisfied very, very quickly. So you're buying something and you have a small downtime or slowness, that puts you off your business, right? So service reliability is not only important for large banks, real-time critical transactions, even very small startups, it's super important, right? And that doesn't mean that people are not aware of it while building. Your services are always built with redundancy in mind, right? But still, outages happen. It's never a question of 100% reliability. It's always how many nines you have in your reliability. And also, it's not proven all the time. This year, you did have only 1 hour outage overall. That doesn't guarantee the next year you will have 1 hour, right? So your reliability can go down anytime because so many variations are continuing to happen underneath the stack. So service reliability itself is more important, and also you cannot rely on the service being reliable, even though you're almost always putting more and more effort, right? So because of this, these two terms are very important in the service reliability business. And how often are the failures happening, right? Mean time to fail. And it has to be increasing rather than decreasing, right? So the distance between the failures have to increase. And even if they happen, you have to be able to recover fast, right? You cannot have the recovery of a few minutes. It has to be less than 30 seconds. That has to be your key for keeping up your the net promoter score up or reputation, all that stuff, right? So these are another two factors that are important. So if downtime is inevitable, right, how do you increase the reliability, right? You cannot avoid downtime. It's only a matter of reducing the downtime or increasing the recovery time, right, making it faster. So one thing is you go back and do your systems better, right? Do functional testing, system testing. Why did it go down? Or there is heavy load, so do load testing. And then many of us continue to do failure testing as well, right? So this we can increase, and also we can introduce a new type of testing into your DevOps to reduce downtimes overall. So that is chaos testing. So chaos testing is more of a culture rather than doing some ad hoc testing. It has to percolate into every aspect of your DevOps, right? A popularly known use case of SREs will do chaos testing. Yes, that is true. SREs will have to do chaos testing, but the new mantra is chaos testing is an extension of your current engineering practices, right? And the tools are made simpler to make them available for the regular usage by DevOps teams, right? So that's what the need for chaos engineering is. So what is chaos engineering in layman terms? If some of you are new to the chaos engineering concept, it's simply put, keep breaking your resources. If a resource can go down, it will go down. So why not wait? And let's try to put it down and see if your redundancy expectations are met or not. All right. And instead of waiting for it to happen at a random time, if you're continuously validating that failure is not causing your outage, that's something good to happen. And there is good inertia, as you can see that, we're already having issues. Now you're bringing more issues. Yes, that's how you do, but you have more, it's a controlled chaos, controlled failure with control on blast radius, right? So you are ready to contain the failure and you're more prepared. So let's do and find the unknowns, weaknesses, and then start fixing them, right? So the moment you do chaos engineering, beginning of the chaos engineering, your system becomes more and more dynamic. In the beginning, you will have more uncertainties and you'll get more bugs, but eventually it settles down. And then as you start automating these things into your CA and CD areas, left shift, you will start seeing a structural improvement in your reliability mechanism or strategy. So as I said, this is more important in cloud native space, primarily for two reasons. We are, as cloud native developers, we are forced to think only in the code that we write, right? Because now we are running our app inside a container, which has a limited scope, more APIs surrounding us, of course. And your app is less than 1% of the whole stack sometimes, or less than 10% of the whole stack, even though your service is running purely based on your application. The stack can have very similar cloud native services. For example, you take Prometheus, CoreDNS, Kubernetes itself. These are fast changing, right? How often does your VMware updates come or Linux update come? But here, it's a big fat service that you're taking, and Kubernetes keeps changing in less than a quarter now, right? And that's supposed to be a super big upgrade, and your app is totally dependent on it. So how do you keep testing it? So that's a recipe for bringing in chaos engineering. So in eventual summary, what's happening here is you're shipping things 10 times faster, and you have 10 times more microservices that you're dealing with. So eventually the complexity of dynamism is 100 times more, right? And how do you ensure everything works when something goes down, right? So that's the use case for cloud native. So you need to bring in a chaos culture into your DevOps, and then start fixing the culture of introducing failures in all levels, right? At the time of merge, at the time of testing reliability, functional testing, the time of pre-production, the time of production, all areas you need to be able to introduce chaos in a regular automated way, and then that starts fixing it. So that's why part of it. And let's go to the why to what part. And how do you rely on a correct strategy? What is the right strategy for doing chaos engineering, right? For picking up certain tools or platforms. We have proposed some chaos engineering principles, right? And these are the 5 principles that we have talked about. One obviously is, we started with open source. If you are doing Kubernetes based chaos engineering, the tool also has to be built and made rugged in the open source world, more tested, etc., etc. And the primary tool or primary element of chaos engineering is the chaos experiment, right? What's the fault that you're injecting? And that fault itself has to be very rugged. You don't want false positives or false negatives. And you're breaking your infrastructure, you want to break it the way you want, right? And so what it really means is that these experiments need to be made super reliable, and you have to be able to rely on them for the job that they do. So it's better that they also are cooked in open source in a community-oriented way. They should have been used by thousands of people, and there's open, collaboration around the usage of it, right? And the third principle is, this is chaos engineering. It's not like introducing chaos ad hoc way for some time. So what it means is that your fault also will mature over a period of time, right? You start introducing the fault slowly and then add more color to it. And then more people get involved in that chaos test. And then they start increasing the tunables and start changing the expectations, etc., etc. So it goes through a certain life cycle, right? Just like your app is going through life cycle, your chaos experiments also will go through the life cycle changes. So you need to be able to manage this chaos resources for software updates. So what it means is that, there has to be an operator, there has to be custom resources, just like how you do Kubernetes development. Chaos engineering also is a cloud native developer experience. And then, once you have a good tool and good ability to manage the life cycle of it, you will have the best results when you do chaos at scale, right? When you're really good at it, more complex outages happen when things are at scale. So you have to be able to manage chaos when your operations are also at scale. So the best way to deal with that chaos at scale is have it GitOps friendly, right? So make the chaos automatically run whenever the changes to the implementation happen, right? If a container version changes, go and run chaos, relevant chaos around it. You don't need to wait for it. So you break all possible things. If because of the new change, if there's a weakness introduced, you have the ability to revert, right? So you can revert immediately than later. And then observability is very, very important in the world of chaos. You have observability systems, you have invested in them for a reason. If something goes down, I need to be able to observe and get back into shape, right? And that's the idea of observability or monitoring systems. So chaos need to be integrated well into that observability, So it's good to have this chaos system, the open source chaos system, also integrated into your observability APIs. So these are some of the
Sorry to break that, Uma. So I have one question here. In terms of when adopting, you wanted this to be part of the pipeline. And do you typically have like a separate cluster where you run this test, or can it be scoped to a single namespace or the whole chaos testing? Do you scope it to a single namespace, and how does it look like in the implementation?
Yeah, so good question. You can do it in both ways. Generally, in Litmus, how it happens is you will set up your chaos infrastructure in a Kubernetes cluster because it's a Kubernetes application. And then the team comes around that tool, and then they build the chaos experiments on that platform, on that cluster, right? And then they push them into a database. Now you have a library of chaos tests to be used by your team. Where can you use them is the question that you are using, right? So if I'm putting them in a pipeline, how do I inject? You can inject them within a namespace, or you can inject across cluster scope, right? And you can do it against some triggers, right? You can manually inject using simple kubectl apply -f that experiment or a test inside a CI pipeline, right? And it runs on the platform because it's operator. It spawns the entire chaos ecosystem on the target. It runs, and then it gives the results, right? So Litmus at least is capable of running within namespace or across multiple namespace or on cluster resources.
Sure. We have one more question from the audience. Can we run this outside Kubernetes clusters?
Yes. So Litmus is, as an application, it runs on Kubernetes. Right? There is chaos control plane and chaos execution plane. The chaos control plane runs on Kubernetes. And at the edge of Kubernetes control plane, the execution plane starts. You can target, for example, VMware, resources, or AWS, GCP, Azure resources, or bare metal resources. You can do them.
So the experience, does it look like you will pass credentials of these cloud environments, and then the simulations happen from outside? Is that what the experience is?
Yes, the experience is somehow you need to be able to provide that access and authentication to the end resource, right? If it is Kubernetes, you will have it a little bit more integrated, right, into the Kubernetes RBAC. And if it is non-Kubernetes, you need to go and provide the credentials, and then we take the credentials, log in into the target system and run chaos, and then send back the results. That's how it is.
Okay, sure. So maybe you will cover this later, but if you can just give a sense of like what all parameters we can change to simulate a disruption, right? Maybe those things. Okay.
Yeah, sure. Yeah, there is a whole bunch of, Litmus is about 50 plus experiments, and on Kubernetes, it can do almost every type of resource, right? A node resource, pod resource, network resources. And within each of this resource, you can do CPU hog, memory hog, and you can have kubelet kills, right? So inside the network, you have the corruption, dropping the packets of slowness, and you have DNS chaos, and you have HTTP chaos. And this list of experiments keep growing, right? From time to time, we started with 6, 3 years ago. Now we have 51. So these are building blocks of different chaos. Then use them, and we have a concept of probes, right? And probes is what happens when you do a chaos. What is the expected behavior? So you use those probes to build a chaos context, right? Yeah, I think he has posted a link here on the chat for everyone to see. There is something we call as Chaos Hub, and that's the open source, marketplace for sharing the experiments back to the community, right? Before we hand it out to demo, I'll just quickly go through this. Now we know why and what, And generally, how is the question, right? And people are very scared to take chaos directly into production. That's kind of a given, right? And we're also not advocating, hey, chaos is for SREs, go and break things in production. That's the first Google search you will get. Breaking things in production is chaos engineering. Well, that's definitely not, false. But real chaos engineering is about building chaos culture in your DevOps. So you start with QA or pre-production, your stage environment, and QA people are the right people to start thinking about chaos. They're more acceptable to taking the idea of chaos because they have some kind of failure testing already. And if you're on Kubernetes, you can ask them, hey, how is your failure testing coming? Well, you do advanced failure testing called chaos testing. Here is the tool, right? So that's a good pitch for your QA teams. And then you can convince your developers to also run this chaos test even before the code gets merged, right? Yeah, so it works with IPv6 too, Ravi. Ravi is asking a question, will Litmus work with K8s using IPv6? Yes, it does, right? That's about.
So there's one more question from the attendee. I can see there are 51 experiments. Where do you see are the most use cases LitmusChaos addressing as of today? I think the attendee wants to know what are some popular test cases that typical people run.
Yeah. Great question. I mean, Litmus is known for its Kubernetes, applicability. So most of these experiments are always started on Kubernetes. Within Kubernetes, the most common fault that you can relate is Kubernetes pod delete, right? Pod deletes, you see that failure all the time, right? It's not that, if a pod is deleted, something bad happened. Some pressure is put, Kubernetes reacts by deleting the pod, right? So it is a fault, but it is always happening, right? And you want to be able to test your application behavior when a dependent pod goes down, right? Or your service behavior when your pod goes down. So how fast do you come back with, right? So the most common and must to do experiment is Kubernetes pod delete. You start with that and then start writing the expected hypothesis or steady state hypothesis and start validating. You might be surprised how vulnerable the systems are against certain pod deletes, right? Sometimes, and especially in the hyperscaler environments where you do a pod delete, your pod takes some time to come back, and your hyperscaler can go ahead and then putting one more resource because something is not working. And then I might be having a need for more resources, one node gets spawned, right? So there was a case where a simple pod delete experiment caused a cloud environment to add tens of nodes, right? Just because the pod is coming up slowly. So under certain load conditions, right? So this is a very popular experiment to answer the question, Kubernetes pod delete. And then people slowly go as a next step, go into network latencies, and then also get into network corruptions. And then DNS chaos is another popular experiment, right? DNS service and availability is a very common thing. So you have to be able to test your service against such a failure. Right. Coming back to here, the maturity model is you start with QA and then have you integrated with dev. That means you are running a mature chaos system. Obviously, ops, are you running chaos in production? Wow, that's great, right? And where you start, the false, if you take the layer, is if you are running at the application layer, that happens almost always as the last layer, right? You always start with infrastructure resource failure and then go to the message queues, API servers, introduce faults into APIs, and then go to your database services and finally your applications layer, your own application, you can have chaos. So it is another way of looking how the chaos maturity happens within your environment. And the other one is a way to look at is, are you integrating your chaos engineering with your monitoring systems, right? Are the SLOs integrated with your chaos? For example, you may be having an advanced SLOs to monitor the service levels, and then you introduce some chaos, and then as a result of chaos, you should be automatically verifying the SLOs around that, right, as a result of the chaos. So that's a kind of an advanced configuration. Similarly, your dev metrics, right? In an advanced or a matured chaos model, your developers are looking at, my chaos experiments are passing, resulting in all successful chaos test execution before the code gets merged, right? So that's another way of looking advanced chaos engineering culture, right? So I just talked about it. So chaos culture is always about including all divisions of or systems of DevOps, right? So I'll hand this over session to Nilanjan for a demo, but Litmus follows all these principles. It's a popular project in CNCF world for its capabilities in Kubernetes, and recently we added non-Kubernetes capabilities as well. And we see about close to 2,000 installations a day of Litmus, so it's a popular one. And importantly, we have a monthly release cadence for more than 3 years now, right? And there are multiple stable releases continuously we made. It is a credible, stable platform adopted by a large number of scaled users, right? So these are some of the use cases to end this session with before we give it to demo. You can use chaos and Litmus in many ways, unlike what you otherwise see as a chaos engineering use case only for ops. The most interesting one also is if you have invested in performance testing, add a color of chaos to it, right? And you might see what your performance test is missing. If you have invested in good observability system, bring chaos and then see if your observability system is working or not. And human ops also. You may have a good SRE team and recovery team and see if your human operations are working by doing simple game days, right? Bring a failure and is your system that is set up to react, is reacting faster or not? These are some of the ways. And then, if you have a good CD system, right, continuous deployment, add chaos to it so that you are adding the verification of your continuous deployments as well. And of course, pipelines, and of course, advanced value testing in stages and all. So chaos can be applied in your regular investments, and this additional investment of chaos thinking will add, verification capability to your existing day-to-day life in your software engineering. So I think we can jump to demo, but in the demo also you will see there is a chaos center where everybody logs in. Everybody means your team members, and then you can build chaos experiments around various resources, Kubernetes or bare metal or multiple cloud. And while building these experiments, you have much of them available. If not, you can actually use the SDK to build a totally new experiment. It's available in 3 languages at the moment: Golang, Python, and Ansible. And there's another capability called Bring Your Own Chaos, where if you have some logic of a failure test, you can just simply containerize it and then use our SDK to create a new experiment and throw that container in, and you have a new chaos experiment, right? So that capability is also there. So using these experiments, you build chaos tests or chaos workflows, chaos scenarios, and there's a good API available for manipulating or scheduling, orchestrating these workflows. And you also have GitOps enabled so that these chaos workflows can be triggered. And you also have probes, litmus probes, which are nothing but a declarative mechanism to define your expected behavior around chaos, right? There are multiple probes like Prometheus probes, command probe, HTTP probe, Kubernetes probe. These are like advanced features which will help you handle your chaos steady state behavior. And then of course use this against this following use cases. So with that, let's go back to Nilanjan for a detailed demo. And in the meantime, if there are some questions, Chakri, I can take.
Sure. I think everyone is excited to see the demo, but I'll make sure if anyone is asking questions, I'll put it forward. Okay.
Thank you so much, Uma, for handing it over. So, yep, give it a start. Before we jump onto the actual demo, I would actually like to reiterate one of my favorite sayings, which I actually keep on reiterating, that the successful chaos engineering practitioners come to master the skill of chaos engineering as an applied practice so that they take it as a case-by-case approach to leverage the most results out of it. So what does that mean? Well, every chaos engineering practice itself is very unique. At least that's what we have identified as LitmusChaos authors and LitmusChaos owners, you can say, product owners. We have seen people apply chaos engineering in many different ways to leverage the most results out of their own use case. And that's what is important to understand, that how unique is your use case, and therefore how you can build your own unique use case for your chaos engineering requirements. So the most effective way to do is having a handy tool at your disposal, having too many weapons in your arsenal, which can help you shape these chaos experiments and chaos workflows. The idea, of course, remains that you should be able to create complex real-life case scenarios which can mimic the real-world failures that you might face in the real world. So how would you do that? Well, Chaos Center is the perfect answer to this. Chaos Center, or basically LitmusChaos, is an effort at enabling the developers, the SREs, QA personas to create these complex real-life chaos scenarios in a simplified manner. And when I say simplified, well, it's as simple as declaratively defining your expected chaos behavior, and then bam, you are right at it. So in order to better understand all of these Nixon features that are included within LitmusChaos, let us take a tour of Chaos Center. When you first arrive at Chaos Center, you will be able to see your admin dashboard. This dashboard contains the history of recent workflow runs which you would have executed in the past, the agents, the projects if you have any, and so on. Let us understand each one of these in detail now. The workflows in themselves are nothing but the chaos scenarios that you want to create. We essentially regard workflows as a collection of chaos experiments that you might have. So understand it in this way. Whenever your system undergoes a chaotic scenario, it is never the case that, well, there's only a single failure. It's usually a cascade of failure, because whenever one of your microservices go down, there's a very good chance that a dependent microservice is also going down. So the idea is to create these chaotic scenarios which are correctly mimicking the real world failure scenarios, which you might encounter out there in the wild. So how do you do that? Well, the answer is very simple. We basically combine these different chaos experiments in whichever order that we like to create a chaos workflow. These chaos workflows are representative of the real world failure scenarios that we want to simulate, and therefore are available to us in form of different collection of different chaos experiments. So for an example, as you can see, I have 3 different chaos workflows, which will be also executing in the meanwhile, but I would like to just show you that how a chaos workflow might look like. Over here, you can see that we have a set of steps, out of which one is an experiment, and the other steps are basically installing the chaos experiment or reverting the chaos. But you are not limited to only one chaos experiment. You can add as many number of chaos experiments as you please into your chaos workflow to achieve the desired chaos results. And that is the beauty of LitmusChaos, because it gives you the flexibility to add chaos experiments and remove them and basically string in them in any order that you like. Moving forward, we have the chaos agents. Okay, I guess we have a question. So Jonathan asked that besides Probe, what's the best way to abort a workflow during its execution? I would like to answer that. So basically, probes are not for aborting a chaos workflow. Probes are a way of declaratively checking the chaos hypothesis that you want to define for your chaos experiment. So at this time, I think it's good to know that what is chaos hypothesis? Well, when you're defining a steady state condition for your application, a steady state condition being anything that, let's say, I want to always ensure that a certain deployment has X number of pods. And you want to ensure that even during a chaotic scenario, this condition is maintained. The X number of pods that you're basically able to see in your steady state should be maintained. Or more realistically, if that pod is serving a website, let's say, you want a certain SLA to be maintained against that website. That is, let's say, the latency should be up to a minimum, realistically minimum value. So that kind of a hypothesis validation can be actually be validated in an automated fashion, and at that in a declarative way using Litmus probes. So if this information sounds a bit intimidating, don't worry. We'll be covering this in a very detailed manner while I'll be going with the demo. I hope that answers your question, Jonathan. All right.
Yes, thank you.
Sure. So as I was saying, let's jump on to chaos agents. What are chaos agents? Well, chaos agents are essentially the way to target multiple Kubernetes clusters at once. What you would want ideally is you want to have a single control plane from which you can perhaps control the injection of chaos into multiple Kubernetes clusters. How do you do that? You do that using chaos agents. So chaos agents enable you to install an agent basically within your external Kubernetes cluster. And from there, you can basically leverage a single chaos control plane to target that external cluster. And for that matter, you can have multiple chaos external agents, which you can install on your external Kubernetes cluster. So the process of installation of these agents is very simple. Basically, we have something known as LitmusCTL, which is a command line utility, which you can use in order to set up the installation of your chaos agent within your external Kubernetes cluster. So as you can see right now, I have only one agent called a self agent. So what happens is when you're installing a LitmusChaos control plane, as part of that installation, you also get the execution plane installed by default. That is, you can say that every control plane installation for LitmusChaos comes with a default agent, which allows you to target the chaos into that particular cluster as well. So this is that agent, like this is the self agent for us. Moving forward, we have the Chaos Hub. You might have already seen Chaos Hub a while ago since I had shared its link, but Chaos Hub is nothing but an open source marketplace for all the different chaos experiments that you have as part of your LitmusChaos. What's so special about this Chaos Hub is that while it has all the open source experiments that you can have as part of Litmus, you also get the option for adding your own Chaos Hub. So why would you want to do that? Well, as an organization, it might very well be the case that you're developing your own chaos experiments. As I had emphasized at the beginning, every chaos experiment practice is unique, and you would like your chaos experiments to be tailored as you want. So in this pursuit, of course, you can develop your own custom chaos experiments. You can pretty much leverage the SDK to do that. And it's a very simple process. But once you have actually created these experiments, how would you maintain them? how would you ensure that your team is able to collaborate on these experiments with the purpose of running them here in the Chaos Center? Chaos Hub is the answer for that. You can add your own private Chaos Hub here at LitmusChaos, where you can have your own private Chaos experiments, which are not part of the public Chaos Hub. So that is very much possible. And in this way, your organization can ensure the inclusion of all the different kind of personas that are in your organization, and they can collaborate the practice of chaos engineering within them. All right, so we can move on to the next section, that is the analytics section. What we wanted to achieve with analytics is basically we wanted a way for our users to perform their workflow statistics analysis. This is important because it's not only about running the chaos experiments, it's also about being informed that what your chaos experiments are actually doing within your cluster. That is, whether they're failing or not, what is the rate of their success, and all the different information that comes with them. So when you are basically getting an access to these kind of information, you can leverage them in order for different kind of data science analytics or even machine learning analytics to step in. And these this ecosystem can basically aid in the sustenance of your application and understanding that the correlations between the user behavior and your application behavior, essentially. So as part of our analytics suite, you can have quite a different options that you can configure. You can also add a data source to your LitmusChaos, which will help you create interleave dashboard right here within Litmus, and you can monitor your application metrics right from here. But at the same time, you can use any external observability tool as well. It's completely up to you. So for our demo, we'll be using a Prometheus data source along with the Grafana dashboard. So moving forward, we also have the different options for teaming over here. But before we jump into that, we have a question. Is it possible to connect New Relic for analytics? Okay, I'll take that question. So currently we don't support New Relic, but of course in our future iterations for Litmus, we are definitely planning to go ahead with more types of data sources, and so that it can be useful for other types of data sources as well. Litmus can basically be integrated, but we are still looking into that feature. All right, so as I was saying, we have our teaming section over here. The teaming section is one of the essential parts of LitmusChaos 2.0. And this is the reason that basically the teaming is possible. And while we say teaming, it's more about collaborating with the chaos engineering scenarios. Let's say you have your teams, the SRE personas or QA personas who are responsible for collaborating on these chaos engineering practices. You want your teams to collaborate, create new chaos experiments, observe their results, so on and so forth. And you want to do this in a non-disruptive way so that the personas that you have in your team should be only given the role that they are entitled to. That is, let's say if someone is there just for viewing these chaos experiments, chaos workflows, then they should be only able to view these and not run these. Then you have editors and the owners of these chaos centers, that is basically the admins, who should be able to control the more disruptive aspects of chaos, this chaos center. So teaming section allows you all this. It allows you to connect your teammates with your chaos centers, invite them, and basically help them. So the user management is more or less about that only. When you have your users, you can give them different roles and so on and so forth. Then comes a very advanced feature that we have as part of our LitmusChaos, which is known as Githubs. When we discuss Githubs in terms of LitmusChaos, we have two types of Githubs here. First is the front-end Githubs, and then we have the back-end Githubs. To best differentiate between these, the front-end Githubs is basically using Git as a DB. What we do here is basically have a Git repository. It can be remote or it can be local, basically, and you can have this repository as your single source of truth for all the chaos workflows that you're creating. So what is the advantage for this? Well, all the different teams that are working along in your chaos engineering practice can basically integrate this Git as a DB for their chaos engineering practices. They can commit their chaos workflows there, and whenever a commit is made, you can say that pretty much the source of truth is changing. So therefore, the source of truth remains the same for the entire team. Everyone gets a clear picture of what are the changes that are coming to the workflow, since they are localized at a single place, Git. And of course, it can also be automated to, let's say, whenever you are pushing a change to your workflow inside your Git DB, it's propagating here and prompting a new chaos workflow. That is also possible. And then we come to the backend GitOps. The backend GitOps is a very advanced feature here as part of LitmusChaos. And what it simply means is that we can define the some kind of policies according to which the chaos workflows can be triggered. So these policies are basically conditions that we define which can be monitored for within our Kubernetes cluster. We can declaratively define what are the conditions for the steady state that we want to maintain. And if one of those conditions is met, let's say that this condition can be anything that, let's say the node count comes to a certain number, then we want to create and run this chaos workflow. That is possible. Or let's say the number of pods exceed a certain number, then we can run a chaos workflow. All these conditions can be declaratively defined here as part of the backend GitOps. So we have a question, says that does a single chaos center support running chaos experiments across multiple clusters with RBAC? Yeah, you can certainly do that. That's the essential idea I was trying to establish earlier. You should be having a single chaos center, and then you would want to target multiple external Kubernetes clusters. That is certainly possible. The chaos center is you only need one chaos center installation. And from that, you can have different external clusters, which you can target. All right.
And we assume that can also integrate with other OAuth system for login, like the SSO.
Yes.
You won't. Yeah.
Yeah, I can take that question. It's possible using DEX. We have DEX support, which can be used to, it takes some work to get it done, and there are some documentations available. It's not like directly integrated into the UI, but yes, it's possible. People are using it.
Using DEX, okay.
Yeah.
Cool. Awesome. So let us quickly also take a look at image registries. So the essential idea is that you should also be able to run your LitmusChaos in your on-prem. In on-prem environments, we often observe that you have your own air-gapped environments, which is maybe not publicly accessible. So what would you do in that case is you can have your own image registry where you can push all the relevant LitmusChaos images. And therefore, you can use these images, fetch these images from your image registry instead of the public image registry that we have for your chaos center. So that basically like takes us to an end mostly about an entry of like a chaos center trip to what chaos center can really do. Before we actually move on, these are some of the stats that we have as part of this chaos. You can see that like these are some of the stats that is applicable for my chaos center. But then we have the last community tab where we'll be able to see the propagation and growth of the chaos LitmusChaos project. So of course we have 51 public experiments right now with more than 500,000 operator installs and more than 900,000 total experiment runs. We have around 2.6 thousand plus GitHub stars, and I guess the graph speaks for itself. We have seen a tremendous amount of LitmusChaos adoption ever since the beginning of the project, and it's only going up. Yeah, so with that, I would like to define what are the things that are we going to do today as part of our demo. We'll be first of all looking at how we can build a chaos workflow using our chaos center. will be executing that workflow and understanding how we can observe a chaos workflow and understand that its impact on our application. And after that, we'll also see that how we can integrate chaos engineering, or more importantly, how we can trigger chaos workflows for LitmusChaos using a CD tool, that is Harness CD. So we have a large agenda to cover. Let's dive right into it. Before we dive into how we can create a chaos workflow, I would like to show you an application. So the application that we are going to target today is called Sock Shops. So this is a typical e-commerce application, you can say. You have socks here because, well, who doesn't love sock? Everyone comes to buy this sock at this website. And what's so special about this website is that it's completely composed of Kubernetes microservices. You have a bunch of deployments for all the different aspects of this website, as you can see. You have your catalog as a deployment. You have your cart as a deployment. You have your authentication as a deployment, so on and so forth. So what we are going to do as part of our demo today is we are going to check the resiliency of our catalog deployment. I can actually tune back into my Kubernetes cluster and show you how these deployments look before we go ahead. So these are all the microservices that are there as part of our Sock Shop application. So you can see that we have carts, catalog, we have orders, we have a few different backend components like a message queue, then we have shipping, so on and so forth, and a user login, like a user login as well. So out of these, we are only interested on the catalog. We want to check the resiliency of how our catalog deployment is resilient. So the exact test that we are going to do today is known as the pod delete. As Uma had already mentioned, it is one of the most popular chaos experiments that everyone wants to perform because, well, everyone wants to know the impact of a deletion of a pod because, well, pods are the last line of defense. It's like it's the only thing that is basically deploying your application or hosting your application. So with that, I would actually like to begin the steps which we follow in order to create a chaos workflow. It's very simple. We just select schedule a workflow. And here you have the option to select your agent. As I had earlier explained, we have the self agent, that is, we are going to target the chaos in the same cluster in which our LitmusChaos is installed. So we'll be using the self agent. We'll go next. And now we have a bunch of options from where we want to start creating our LitmusChaos workflow. We can either choose one of the predefined workflow, which is actually useful if you are a beginner and want to get onboarded to Litmus. These are a few beginner-friendly scenarios which can run with zero configuration. You can basically just run them, observe that how they are running. Basically, they usually involve installation of some of an application and they run, and then we run a chaos workflow on them, after which the application gets deleted. But we don't want that. What we would instead like to do is do a chaos hub, like choose an experiment from chaos hub. And that is the LitmusChaos hub that we have. But then again, you have other options as well. Like you can have a template which you can create. And these templates are created out of, let's say, whenever you are creating a chaos workflow, you're running a chaos workflow, you might want to save them for your own reference so that you can rerun that chaos workflow later. So it's a handy way of just saving and quickly executing a workflow. And the last option is importing a workflow using YAML. Essentially, when we are defining a chaos workflow, it's nothing but a workflow manifest, a manifest which allows us to have these different configuration for our chaos workflow. So you can directly upload that manifest over here and it will essentially cause a chaos workflow to be created. So we'll go with our intended option here, that is choose an experiment from Chaos Hub. We'll go next and let us configure here. So we want to do a catalog pod delete. I'll name it as such. So now comes the essential part where we'll be actually defining our chaos experiments. If you have any pre-notion of how difficult chaos engineering is, let me break that for you. We'll simply choose a new experiment that we want to add. I'll choose the pod delete experiment over here, click done. And we can see that over here, a new step has been added, that is the pod delete step. Let us go ahead and edit this because, well, we want to specify our target application as well. So over here, we'll be choosing the target application. And here I need to provide the namespace in which our target application is lying. So the namespace in which our SockShop application lies is the SockShop namespace. And the kind of deployment it is like the kind of resource it is as well a deployment. But you can see that we can also target our stateful sets, daemon set, deployment config rollout, so on and so forth. We'll choose deployment here. And then we need to target the label that we are intending to basically target. So we want to target here the name catalog because, well, as I said, we'll be testing the resiliency of the catalog deployment. And with that, we have configured the application. We can go next. And now we need to add a probe. So if you remember, what we are trying to do over here is we want to establish that whether our catalog deployment pod is resilient or not. Or more specifically, we want to see that when we delete one of the pods in the catalog deployment, what would be the impact of that? Whether will we still be able to access our application or not. So as you can see, it is still applicable, accessible right now. If I refresh the page, everything is fine. But the question is, while we are performing this pod delete experiment, are we still able to access it or not? And we want to define this exact condition in a declarative way. So probes will let us do that. Let me show you how. We just need to name the name of a probe, and then we need to define what is the type of the probe. Here we have HTTP probe, Cmd probe, Kubernetes probe, prom probe. HTTP probe, as the name suggests, will allow you to define HTTP condition, which you can validate as part of your chaos hypothesis validation. And then you have your Cmd probe. The Cmd probe essentially gives us an option to define a custom bash command, basically, which will be run as part of your chaos validation. So we'll be also defining some kind of an output, which will be expecting while that command is run. And if the output is matching, then we can say that, well, our probe is valid. Same goes for Kubernetes and prom probe. We can give a prom query or a Kubernetes command, basically, which we can validate it as part of our probe validation. So we'll be going with the HTTP probe here because we just need to verify that whether our SockShop application is still available or not during the pod delete experiment. We need to add some kind of a timeout for this. So let us add a 3-second timeout, and we'll just retry once for after an interval of 1 second to verify that, well, it is actually down or not in case it is down. And next comes the URL that we want to add. The URL that we are going to add is nothing but this catalog. But what I want to show you is an API endpoint. The API endpoint, I hope it's visible. The API endpoint that we have over here is nothing but the API which is being displayed here as part of your SockShop application. This exact API endpoint, which is available at /catalog route, is enabling for this catalog to be visible over here. So it makes perfect sense for us to look out for this API endpoint if we want to monitor that whether it is available during the chaos or not. So I'll simply add this catalog URL over here. And then we'll define the criteria for this probe to be passed. What we want to essentially do is we want to send a GET request to this URL that we just provided. And we want to check that whether the response code is equal to 200 or not. So as you can understand, if the response code is equal to 200, it simply means that our URL is still available, and therefore we are still able to carry forward our usual business, like our website is still available and therefore everything is fine. But in case we are getting a different response code, or we are in fact not getting any response code, we can be assured that something is not quite right. We can therefore flag this experiment as the steady state condition is essentially failing. We are unable to validate our hypothesis condition. So let me add this probe now. And it has been added over here. I'll go next. And finally, I'll just assign a few tunables over here. We have a total chaos duration, that is for what duration you want to perform this pod delete. That is, we'll be having multiple iterations of pod delete as part of this experiment, and for how long you want these iterations to carry on. So we'll just have it for 30 seconds right now. And we want to also define the chaos interval over here. And the chaos interval is nothing but the time duration between successive chaos iterations. That is, what is the time duration between, let's say, successive pod deletions. So I'll also go ahead and define that 30, because let's just delete it once and see what is the result. For pods affected percentage, we can pretty much say that we want to delete the only pod that we have available. I'll just like to go back to my ID and show you that, well, here in the catalog, we have only one pod available. So I think you can pretty much anticipate that what's going to happen if we delete this single pod, but let's just go ahead and see what happens. If we try to delete that pod, and I'll click finish over here. So that's all the configuration that you need to define your own chaos experiments. It's as simple as that. You can basically prepare it in under 2 minutes, or essentially very quickly. Before we actually go ahead with the execution of the experiment, I'd like to show you the Grafana dashboard that we have over here. This Grafana dashboard is for the SockShop application that we were able to see earlier. You can basically take a look at all the different pods that you have over here, all the different deployments that you have. You have your orders, you have catalog, you have payment, shipping, users, so on and so forth. What essentially this dashboard depicts currently is that every microservice deployment is working correctly. The QPS, that is queries per second, is being served quite nicely for each one of these deployments, as you can see, and there is no issues with any of these now. But it would be interesting to see that in the event of the chaos, what happens. So I'd like to go back to my chaos center. With this, we have our chaos experiment ready. I'll just turn this revert schedule to off, because let's see a few logs that will be generated as part of this experiment, which will help us to better understand why the outcome of this chaos experiment is as it looks. It will basically give us some insight. So with that, I'll go next. And we come to reliability score configuration. So what is reliability score? Well, it is nothing but a measure of how successful your chaos workflow is. Let's say that you have multiple chaos experiments as part of a single workflow. So whenever you are having multiple chaos experiments, you can have different weights for each one of these. I can actually show you that if I just go and add a new experiment. Let's say that I'm adding a second experiment, that is pod network loss, let's say. As you can see, we have already added the new, just a second. As you can already see that we have added a new pod network loss experiment over here. We can in fact also tune in the order in which they can be basically be executed. Let's say that you want to run it in parallel with your pod delete experiment, you can do that. Or you can have it as a serially occurring experiment after the pod delete experiment. You can do that as well. It's totally up to you. But the essential idea that I'm trying to create over here is, if we go next, you can see that right now we can configure the reliability score for each one of these experiments. So the idea is that, as I said, reliability score is nothing but a measure of how successful your chaos workflow is. You can give different weight for each one of these experiments. And by doing so, essentially, you are giving different importance for your different chaos experiments. By different importance, I mean that, let's say you want to emphasize on chaos experiment more than another chaos experiment. You can do it as such. So effectively, when your chaos, when your resiliency score is calculated in the end, let's say that one of the experiments is not really performing up to it, then you can reduce the weightage of it and claim that, well, this experiment is less relevant to me, and therefore I don't really care much that if its score is a bit less or if it is failing sometimes. I'm not really concerned about it. That is possible, and that is how you do it. So essentially right now, let's say we have two experiments, and if they both carry equal weightage, that is 10 and 10, whenever you are basically configuring your reliability score, if one of them fails, essentially you get a 50% reliability score. But if you take it all the way to 0, then no matter the outcome of this pod network loss, you'll be always be judged on this pod delete experiment only. So
yep,
with
just
that,
a short information. We have about 10 minutes left.
Oh, okay. All right, I'll just zoom past the demo then. All right, so let me actually revert this. I'll just go ahead and show you that how to run the experiment now. The schedule is something you can basically schedule this experiments as a cron job. So we'll just skip for that. And we come to the end of it. So we'll just go ahead and click finish over here. The catalog body workflow is currently running. Let us observe the outcome of this workflow now. Meanwhile, we have push. Okay. So what's happening right now is the chaos workflow experiments are getting installed over here. As you can see, the chaos experiment is being installed, the pod delete experiment that we had defined. And we can still be assured that our catalog pod is running fine. We can see that no harm whatsoever. The experiment is yet to start since, but as soon as the experiment starts, we'll be able to see the effects of the experiment. So we can see that the experiment is about to start now. So yeah, we are good to go with the pod delete. And the best way to know that whether this experiment is working or not, we can check for the Grafana dashboard and notice if we can see any changes over here or not. As you can see, since we have targeted our catalog deployment, we should be able to see some kind of change here if applicable. And as you can see that I just changed it to last 5 minutes so that we will be able to see the metrics better. And as you can see, our catalog is taking a hit. Queries per second is taking a hit. And at the same time, you can see that all the other deployments are working quite fine, but our catalog deployment is not quite fine. It's queries per second is progressively going down while the latency, the average latency is going up. And that is a clear indication of what is happening. Since our pod is now deleted, it is not available. Therefore, the queries per second is going down. Our application has essentially become unavailable. To verify this, if we just reload this application page, you can see that the catalog page is empty. I can again reload this and you'll be able to see that it's not coming up. It's not there. To finally verify that if it has actually happened or not, you can see here in the catalog deployment, there are only 0 out of 1 pods available. So what does this mean? It essentially means that our application is not resilient. It essentially indicates that our application needs some kind of mending because our hypothesis condition is proving to be not true. What we had earlier expected is that during the chaos, our application should be available and we should be able to see the effects of the application. We should be able to still be access our application during the chaos, but that is not happening. So while our chaos experiment is executing, what do you think can be done to mitigate this issue? Well, the most obvious answer that comes to our mind is we can simply increase the number of pods. Because if we have more number of pods, then, well, it is a redundant microservice. And if we have more number of pods, then we need not basically be worried about if one of the pods go down, because our application should ideally still be available. Maybe there will be some hits about queries per second because there will be less pods to sustain our microservice, but still we should be at least be able to visit our application and it should run correctly. So let us take a look at how we can do that. And at this point, I would like to introduce the Harness CD. The Harness CD is one of the continuous deployment tools that are available out there, which is as part of like Harness offering. And we'll be showing you that how you can integrate your chaos engineering practices with Harness. So I'll just quickly run down what we have done so far. Like you can see that we have this pipeline over here, Sockshop pipeline. And as part of this pipeline, you have your deploy Sockshop step, which essentially deploys your application. So you can consider this as a pre-prod environment where you can deploy your application and then run chaos as part of it. So as soon as your deployment step is complete, you can go ahead to the catalog chaos step, where we'll be automating the process of running this catalog chaos, pod delete chaos. What we are essentially doing in this step is we are using the Litmus API in order to basically target the one of the workflows that we have created in our chaos center. So if we go back in our chaos center, you can see that this experiment has actually failed as expected. And if we take a look over here, not going directly into the logs, if we just take a look at our chaos result, you can see that the reason that it has failed is because our probe success percentage is 0. But we had defined that our application URL should be available. That is not happening. Our catalog probe has actually failed and it says better luck next time. So how we can fix it? Well, as the answer is basically suggesting, we can basically bump up the number of deployment pods. So I'll do just that, but I will do it in a Githubs way. So the thing is that like the application that you saw earlier, it is like being governed by this workflow manifest. And what I'll do is I'll just bump up the number of replicas here for the catalog deployment to 2. I'll just add my commit over here, and then I'll push this commit. What will happen is that this workflow will get submitted to GitHub repository. This is the repository, and I have defined a webhook over here which should enable the this pipeline to run. So let us see whether our pipeline runs or not once we are actually pushing our workflow. So as you can see right now that none of the deployments are actually currently running, but I'll just push my changes here. So yeah, I've pushed my changes, and as you can see right now, our deployment just got triggered. So as part of this deployment, we should be able to see our replicas for these catalogs scaling up to 2 from 1 at least, because that is one of the major changes that we have done. And as you can see right now, that process has actually already begun. From 1, we have like shifted to 2 over here. The container is still coming up, I'm assuming. We can see that in pods. Yeah, the container is still coming up for the catalog. And as soon as the container is coming up, we'll be able to again run the chaos workflow in an automated fashion from here. So meanwhile, while the application is scaling up, I would like to take up any questions based on what you have seen so far.
Sure. Yeah, I have a few questions. I think in the recent takeover of the chaos native, right? Like, what is a roadmap or what is the future of chaos native?
Oma, would you like to take up this question?
Yeah, sure. So as far as the Litmus project is concerned, things are going to be even better, right? So Chaos is, as an open source project, is totally committed from Honest side. We're going to accelerate the feature contributions even further, right? And we're looking forward to working with the community. The same team has moved over here. We're adding more resources into the open source team, right? So nothing changes from as far as the open source contributions from Honest is concerned. It's a great question. And of course, for the enterprise users, there will be an enterprise edition that we have already announced. People who are looking for enterprise support around Litmus, Honest will provide now.
Will there be any licensing changes, Uma? Or is it going to be same?
Yeah, so the licensing, there is a free SaaS that we have started offering for Litmus community. It gives up to 2 agents and certain number of workflows. People can get Litmus control plane for free, no questions asked kind of a thing. And the license wise, I think there will be Chaos Native also had an enterprise edition, and Harness also. Now we have converted that as into a Harness Enterprise Edition for Chaos, and the pricing is still being worked out, but licensing is very, very similar.
Okay, and I have one more question from Jonathan. If there were more experiments in this workflow, will Litmus move to the next experiment when a probe failed, like in the example?
Yes.
Yeah, I'd like to take this question. So thanks, Uma. So yeah, essentially what happens is the outcome of any experiment is not dependent on the other experiment. Your experiments would run regardless whether the probe fails or any issue occurs within the experiment. And in the end, the resiliency score of the entire workflow is calculated based on which number of experiments are run and then what is the individual weight for them.
Yeah, also, if you're not in the community, please join us on the Litmus channel. We'll be happy to help around more queries there. Help you get started as well.
Yeah,
definitely.
So yeah, I'll just like to show you something really quick. So as you can see, our catalog has been scaled up, and as part of this, what we had run earlier, like over here, the catalog has been actually, this workflow has actually been triggered, and as part of this, new workflow run is occurring over here. Meanwhile, you can see that we have already recovered from our earlier outage. Like our application is again working right now, but as part of this new pod delete experiment, let's see what happens. We can observe the same at Grafana as well. As you can see, the application is back up. We can see that the graph is climbing up again. Let us wait and see like what would be the impact of this again chaos workflow. So to summarize, what we are expecting over here is, it is again the same workflow that we have run, but in an automated fashion over here. This goes on to prove that LitmusChaos can very well act as a CD supplement, which you can, and therefore you can add chaos engineering as part of your CD requirements. You can integrate with your CI pipelines. You can add it as part of CD pipelines. You can essentially perform these tests in an automated fashion in your pre-prod or even in your prod, or you can, it is essentially meant to help all the developers who are doing these tests and these tests. So as Uma had earlier explained, we are also following the shift left principle, where we are essentially trying to ensure that developers not only do their regular testing, they also shift to the chaos testing, and tools such as LitmusChaos or Harness CD will essentially help them to shift to these platforms and perform and integrate chaos testing as part of their regular testing. So to summarize what is happening right now, as you can see that our application over here is still available, and that is by virtue of the fact that there are 2 pods out of which we have deleted only 1 pod. As you can see over here, since we have deleted 1 pod, we have only 1 out of 2 pods available, but still our application is not taking ahead since, well, 1 pod is still there. we can see that over here in the Grafana as well, we don't see any outage. So everything is working fine. Therefore, we saw that how we can use the different features of LitmusChaos to understand, monitor, and inject chaos into our target application, how we can interpret the results of a chaos workflow, and how we can remediate these results to mitigate the effects of these outage, the example outage that I shown you earlier. So with that, I would like to wrap up this demo. Thank you so much.
Thanks, Neil, for that detailed demo. It was pretty good to understand how LitmusChaos works. And then I'm sure most of the audience also wants to try out. With that, any final thoughts that you would like to share, Uma? And then we can close it.
Yeah, no, thank you for arranging this. Great questions, of course, Jonathan and others. So you can try out the Litmus yourself by installing, or you can just sign up to the Chaos Cloud as one of the options, chaosnative.com/cloud, or it's there as an option in the documentation also. You get a control plane for free, and then you can just connect your agent and then start working with Litmus, right? So that's, yeah.
All right, thanks for that. All right, so thanks everyone for joining this call. And then Josh, do you have anything to share? Any updates on the community side?
Yeah, we'll send the recording, and Neil, if you could send us your presentations, if that's okay with you, we'll send it out with the recording, and then yeah, we'll have another event. I dropped a link for our next event that's going to be in 2 weeks. So that's it. Thank you, everybody. And
Thank you.
Yeah,
great day.
We'll see you on the next one.
Us.
You're welcome. Take care now.
Thank you, everybody.
Thank you. See you, Chase.
Adios.